Hello everyone, it's indeed inspiring to see you back again, and we are here in this Business Analyst series. We are going to help you with step-by-step journey to learn and develop your skills as a business analyst. Here, you will learn a lot about how to interact with client, how to capture the user stories, how to document them and produce BRDs and SRS, how you can do the data modeling part, UML modeling, software methodologies, agile, scrum and DevOps, so many and so much things to learn. So I insist you to go through this particular series and get an advantage on business analyst.
So we already had a discussion on the UML diagrams, and now let us move ahead and try to see some more. Let's say we want to, once the project is completed, once the project is uh, in the final stage. So at that particular point of time, we have diagrams which are called as component diagram and deployment diagram. So let us try to have them. They basically represent some physical components. Physical in the sense there is some library which we are using in our project. So that library is a component. Then there is some other application which we are using in our project. So that application is a project is a component, and there is an API which we are using, and that API becomes a component. So component diagram has got such entities which are interacting with each other, and they have some existence, but they are software. There are some. I was explaining about the component diagrams, and component diagrams are used for representing some software system components. And here the component could be, for example, some API is there. So we call these things as components. And again, it shows some high level view of the whole application. So here we can see this is a component icon or component structure. We can give it a name. So our application will be deployed on cloud. So we will give it a name as cloud. So, and if we are very much specific, so we can give AWS cloud. So Amazon Web Services cloud. So this is one component. Then we will have end applications, end user applications we will have. So the end user applications, if you see, we may have edge, we can call them as edge devices, EDGE, edge. That means the device which is being used by the end user. So edge device, DEVICE. So edge device is another component. Now we will have here a kind of dependency between them. Dependency. So dependency, edge device now depends on AWS cloud, because the kind of relationship AWS cloud and edge device is having. Edge device receives all the data or whatever computation happens that comes from AWS cloud. So it is coming from AWS cloud. So that is what happens. So this is one component, this is another component, and then they have some dependencies between them. Now there could be an interface also. Interface basically represents, uh, for example, like we want to move out of a room, so there is a door. So door is kind of interface from where we can walk inside the room or we can move outside the room. So that is door. Similar way, windows are there. So windows are also helpful for, let's say, the air breeze is there. So that basically passes by the window. So window is that interface. So interface is that thing which is going to help us uh, in order to make us understand that yes, that component is an interface which is required for communication. So for example, we have a component which is GOOGLE, Google. API. So the Google API normally we use for making the authentication mechanism. Somebody wants to create a new account, we normally have an option to log in with Google or register with Google. So that is an API. And we have, let's say, here the login module. So we have a login module. So now this login module and this, they will have a relationship. So it's a kind of interface. Okay. So login module uses Google API. Okay, so login module uses the Mhm. So login module uses this thing, Google API. So interface one. So here only I can write the let's say Google Google API, and then this could be Google server, not the API. This could be Google or Gmail server. Gmail server, server, Gmail server. So for interface, okay, that is also not required. Okay, so we can have a class itself. So instead of a server, we can here have, this is Gmail, Gmail, server server. So Gmail server. So now we have this Google API, which is being used by the login module, and Google API is actually coming from the Gmail server. So this is a kind of relation we have created. So this is an example of component diagram where we have the primary notation is this particular component. So one component can have interaction or relation with the other component. That is what we actually show over here in component diagram. Then we have deployment. Like after component diagram, then we have deployment diagrams. So deployment diagrams are the final stage diagrams, final stage. Component are basically, okay, the project is over and now let us basically try to identify the components and try to show the relationship between them. But this next diagram, if we see, this is known as deployment diagram. So in case of deployment diagram, if you see, we have nodes, deployment, and communication path. But it also helps us to use the components, because sometimes, because whatever components you have in your system, in the deployment diagram also you can show them. So component diagram only works with components and some libraries, jars, which are called as artifacts, and the kind of relationship between them. Deployment normally has got node. This node is a physical server. Like this represents a physical server. So it is server server. It's a server. Okay. The node represents a server. So we can have multiple such nodes, and the kind of operation which will happen between in a particular node, that we represent over here. So we can have multiple such nodes. This is server one node we have, and similar way we will have another node. Okay, so this is another node which we have, and server 2 is its name, and here I'll just name it as server 1. So two nodes we have here. Okay, one node and two nodes. Now, what kind of relationships they have? If they just communicate with each other, so we'll have a simple straight line, which basically tells that they are able to communicate with each other. But at the same time, we can have some components also inside them. So within them, we can have some components. So this server is basically having some MQTT protocol, protocol. So don't get with the name of that protocol. It is just a message passing protocol. So it has got some MQTT protocol, and this is, let's say, a sender. So we'll have a component here also, RACEIVER. This is receiver. Okay. So now they too also have can have some dependency, like MQTT protocol receiver depends on, okay, it should have been opposite. So receiver depends on MQTT protocol. Okay, so it depends on MQTT protocol. So this is how we can do, like one server is a physical component, another server it is an again physical component, and we can have inside a particular node represents the physical instance, physical CPU. So this is the diagram which is known as deployment diagram. So understand deployment happens with physical resources. So we have physical actually existing resources. With them, basically, the deployment happens. I think we should discuss sequence diagram also. Okay, if you want to represent some, so this is again, if you see deployment, they are again structural diagrams. They're not basically showing any kind of behavior because they just show some static thing. Now, in case of behaviors, activity diagram was one that basically is used for that. Then we have state diagram. State basically means a particular at a particular point of time, what is the state of a system, which means that at a particular point of time, how the system is behaving. So let's take very simple example first. So this is let's say liquid state. Then we have a vapor state. Then we have a solid state. So we have liquid state, we have vapor state and solid state. Okay. Now, normally from solid, the transition is to liquid, and from liquid, the transition is to vapor, and from vapor, okay, there is a transition again to solid. So normally that doesn't happen. It goes from liquid. Yeah, this way. Okay, and from liquid again it goes back to solid. This way. Okay, so this is state diagram, very simple. Okay, once water has got liquid state, water has got solid state and vapor state, and we know that how state gets changed as the temperature is getting changed. We know that thing. Okay, so this is a state diagram where we have states, we have arrows to represent a particular state. Now, many a times what happens, this is one example. Let's have a state, and this particular state is career. Now, career state can split into multiple states: job, business, freelancing. So there are so many options we have today, right? So now here what we will do, here we will use fork. So from career, we will have this as job. Okay, so here we have career, and the career could be into job, could be into business, could be into freelance. So career can have so many options. So this is called as fork. Fork, like the fork we use for having something. So it has got multiple branches. The opposite of fork is join. The opposite of fork. So ultimately, let's say the goal is one, but we have different paths to achieve it. So we may have, let's say, PATH path one. Then we may have path two. Let me have join over here. So path two is there. In similar way, multiple paths can be there. So in case of a join, it is basically there are multiple paths, multiple options, and they are coming and merging back to a single one. And in fork, there is a single option, initially single state. It is splitting into multiple states. So that is what is the difference between join and fork. And let's say now we are about to stop. Whenever we are about to stop, we basically have this symbol. This symbol represents the final state. Now nothing more is there. So it is done. And now we are in the final state. Okay. So from here it will happen. So now we are in the final state. So whenever we want to stop, we can basically make use of final state and we can stop at that particular point of time. Okay. So this one is basically state diagram. State diagram is used for representing a particular state at a particular point. So that is the purpose of state diagram. There are many more, like if you see, these are few I have explained. Now there are many more diagrams, like package diagram, object I have explained, composite structure, then sequence, communication, timing, interaction overview. So there are so many types of charts. One I would like to focus more on is ER diagram. Okay, that is another important part where I would like to put more focus. Yes. Now, once the BRD is over, so BRD content will be referred for creating the SRS, the software requirement specification document. When we are creating the SRS at that particular point of time, it is needed that we design the database architecture of the particular system. That is what is required. So how basically we can design the database? And we all need to understand that every application at the backend uses a database. There is a database at the backend. So I will explain you first that how the database is created. There is a process, step-by-step process is there that I will tell you. Okay. Okay, fine. So here, let's say we are doing data modeling. So data modeling is designing the tables for a database. So we'll have to do data modeling. Now, in this particular data modeling, there are three levels. The first level is conceptual data model. Second is logical, and third one is, so we have conceptual data model, we have logical data model, and we have physical data model. Three basically levels are there. Now, conceptual data model, the first one, if you see, it has got all the tables which needs to be created. Like yesterday, we were discussing about the classes to be created. Now we need to understand that what tables needs to be created, like what all tables will be required. Okay. So many of them will be similar to classes also. For example, we will require a customer table. We'll require employee table. We'll require services table. Then let's say bill table, courses table could be there. This way, yesterday we were pointing out the classes. Similar way, we can have n number of courses, like n number of classes over here in the form of tables now. They will be tables. Now, these tables have got some relationship between them. That relationship is being shown by the ER diagrams. ER diagrams are used for making that relationship happen. Okay. Now, data modeling, let's say we have these three tables in conceptual. Logical will basically ask to draw the logical relationships between them, to also have the kind of columns which are required into them. So for example, customer table. So customer table will be having CID, customer ID. It will also tell to mention that whatever number of columns are there, everything, and what kind of relationship a customer table and an employee table is having. So that also we'll have to mention here only. Okay, what kind of relationship a customer table and employee table is having. Okay. So CID is there along with customer ID. It has C name, it has C email, and so on and so forth. And then let's say we have COURSES courses table. So if we have courses table, in that particular table, if you see, we need to have COURSE course ID. The course name can be there, course name. Okay. Now there will be one more table which I have not put here. That will be enrolled. So here enrolled table would be there. Then who enrolled? Customer ID, he enrolled. With which course? So here basically we will have customer ID, and anything else we have course ID. So this much will be enough to understand that who enrolled and to which course that person enrolled. So this is how we need to basically create all the columns. Physical data model is now this logical data model will also contain that whether it is integer, whether it is a string, string, string is text data. So it also mentions like whether it is integer or string or okay, whatever. It also mentions the size of that integer, size of the string. It also mentions that. Okay, so looking at the logical data model, one is able to create physical model. So then SQL, it is command based. Physical data model is command based data model, and where we actually need to write the queries and commands. So for SQL, we will be using a tool, and this tool is SQL. My SQL tool is there. So I can write my SQL. Yeah, so this tool we will be using, MySQL. Yeah, this is a tool where basically we need to make use of commands. For example, show databases. So this is a command which shows the databases. Then use, I want to use some database, use MyDB. So now it is going to use MyDB database. Now show TABLES tables. So MyDB database has got these particular tables. And what is there inside the table? Select star from student. So nothing is there. It is empty table. Select star from ACCOUNT accounts. So these are empty tables. Nothing is there. So let me use another table database. Show DATABASES databases. Use WORLD world. Show tables. And SELCP select start from city. So this is how it basically stores the data and shows it. Okay. This is called as physical data model, where we are actually creating the tables into a particular software that is called as physical data model. Yeah, going back. So when we are writing the SRS, we actually start from conceptual, logical, and we end up at physical data modeling. That is what is the target of designing a database and putting that into SRS. Okay. Now, before we go to the physical one, it needs to be this first and second needs to be put into ER diagram, something which are called as ER diagrams. So let me right click over here, add diagram, and here we have entity relationship diagram, ER, entity relationship diagram. Entity basically means a table only. So entity is a table only. So now here we can see we have an entity. So this is the entity. What is the name? Let's say customer, courses, and enrolled. So this is CUSTOMER, customer, then employee, and customer, courses, enrolled. Customer, courses, enrolled. So COURSES, courses, and then we will have enrolled, ENROLLED, enrolled. Now Customer basically has CID, CNAME, CEmail. So it has got attributes. So add one to one, no, add node, and this one is add one to many, and this is add many to many. Okay, and this one is add column. So columns we will add. Attributes are columns. Okay, and rest of them are some sort of relationship. Fine. So it has got C underscore ID, customer ID is there. Okay, similar way we can keep on adding columns to it. Another column is C underscore name. So this is another column. So whatever number of columns are there, we have to write, okay, in this particular table. And then after writing all the columns further, we need to make a relation, right? That one customer can go for one course. The answer is no. One customer can go for multiple courses. Okay. One course can be taken by one customer. No. One course can be taken by many customers. So that means here we have many to many relationship. Many customers can take many courses, a many to many relationship. So these relationships also show that what kind of relationship they are. And then customer can be enrolled. One customer can be enrolled one time. Okay, once it has enrolled, it is enrolled. So one to one relationship, one customer, one enrollment number. Okay, so customer is enrolled, or maybe permanent number is there. So one customer will get only one permanent number. Okay, so this is how we show the relationship between the two entities. Now, this is the logical data model, and looking at the logical data model, we should be able to create this kind of table in command line, like what we did in MySQL. We should be able to do this typing in, okay, and we can start implementing that particular database into this particular software. But when this particular content has come to the UML design, which is called as ER diagrams. So ER diagrams are for databases. Databases are there at the back end where all the data gets stored, and through network, internet, that data travels from one place to another place. Okay, that happens. Now, right click, add diagram, and here we have sequence diagram. So sequence diagram has got this particular boundary. We can see that this boundary is there, and we can give it a name. Where is the name? So here we can give the name, and let's say it shows ADMISSIN, admission, PROCESS, admission process. So this sequence diagram shows admission process. Now this admission process, we will have some lifelines over here. So this is a lifeline, and lifeline can be of just a second. Okay, let me bring it over here. Yeah. So we have lifelines. Now lifeline is basically of some entity. So this is CUSTOMER, customer is one entity. Now we will have another lifeline. Second lifeline we have is of let's say ADMIN, admin, and third lifeline we have is of system, SYSTEM, system. So now how does the sequence diagram works? Now from customer there will be a message. From customer there will be a message to admin, and now this message is APPLI, apply for CLASS class. So for some class the customer has applied. Okay, now admin is going to check with the system whether this application is valid or not. Okay, VALIDATA, validate with only validate whether it is valid or not. System is going to give a response Okay, valid or not. So system is going to give validated. Validated. System has given. After the system has given the information that validated, then admin will give back a response to customer. So that this needs to be from here. Okay, done. Okay, yeah, now it's fine. So the sequence was getting disturbed. First one is apply for class. So customer is applying. Admin is validating with the system. System is giving a response validated. Admin is again giving a response to the customer, application approved. This is called a sequence diagram. So we have the entities, customer, admin, system on top. And then we have to represent with the help of an arrow that customer is making some communication to the admin is making some communication to the system is giving back a response to admin, and admin is giving back the response to the customer. So this is a sequence diagram.
If you like this video, please do share it with your friends and those who need it. And don't forget to press the bell icon and also subscribe to our channel so that you can get all the videos notifications readily in your account.